Zeal Education Society, redefining excellence.
So good morning everyone, I am Shantanu Pawar from group number 8 and the topic for VWV we have got is VHDL code for 7 segment display. This video even has the basics of VHDL. So without any further delay, let's get started. Good morning everyone, I am Shantanu Pawar from group number 8 and this is Develop a VHDL code for BCD to 7 segment display. That is our topic. Now this video is actually sectioned into 4 parts. In the first part, we are going to look at what is VHDL, what are its competitor language and what are basic differences between them and also about its history. And in the second part, we are going to take a look at what are the basic elements of VHDL programming, which are 3. Again, they are subgroups. But next, we are going to take a look at what is the logic we have used in VHDL code for BCD to 7 segment display. In programming, what is the logic we have used. And in 4th section, what we are going to see is the simulation of this current project. So, without any delay, let's begin. So what is VHDL? VHDL stands for Very High Speed Integration Circuit, HDL. Actually, if you don't know, HDL means Hardware Description Language and it is IEEE standard, which IEEE means Institute of Electrical and Electronics Engineering. And VHDL is a type of HDL, means it is a type of language which counts under HDL. And if you look at the examples, they are odd parity generator, pulse generator, priority encoder, behavioral model, and etc. Now here are few features of VHDL. As you can see, the first is design methodologies and their features. Second is sequential and concurrent activities. Third is design exchange. Fourth is standardization. Fifth is documentary. And 6th is readability. Next is large scale design, and there are many more. Actually, the VHDL famous for because it can be shared easily, and that was the motivation. And so as you see, there are various languages under HDL, but why VHDL? Like, what are the advantage of it? And as you can see on your screen, it supports various design methodologies like top-down approach and bottom-up approach. Second is, it provides flexible design language. Third is, it allows better design management. Fourth, it allows detailed implementations. Fifth, it supports a multi-level abstraction. Sixth, it provides slight coupling to lower level and designs. Seventh, it supports all CAD tools, and this is my favorite one because if suppose you are using Blender, you can run the VHDL language in that, maybe. And 8th, it strongly supports code reusability and code sharing. This is very important one because that is the reason why VHDL is still famous and it is being used widely. Now there are also few disadvantages of VHDL and they are as listed below. Let's read one by one. It requires specific knowledge of structure and syntax of language. It is more difficult to visualize and troubleshoot a design. Some VHDL programs cannot be synthesized. And finally, VHDL is more difficult to learn. In short, it is extremely hard to understand and learn. But if you know C programming, you kind of understand it, and this is my experience with it. So here are the basic elements of VHDL and let us break them down one by one. So the first is entity, and it is used to specify the input and output ports of the circuit, and there are generally one or more than one ports, okay, or they are bidirectional many times, like you can see here, input output ports, in out. And below here is the syntax of that element. So how we declare is, first we write the word entity and we enter entity name is, we say port, we declare the ports and its type, and then we say end entity name. You can see at the bottom here is a actual example. We say entity or get is, and under that we declare the ports ABC. We declare 2 as in and 1 is out, and at the end of we say end or get. So that is how we declare the entity. Now the second element is architecture. Now what is architecture? Architecture is actual description of the design which is used to describe how the circuit operates. Okay, so it basically contains concurrent and sequential statements, but what is this actually used for? So architecture kind of defines where we are going to use it. Okay, yeah, so let's look at the syntax and example of architecture. Okay, so architecture, name of the architecture of entity name is, and again as we seen above, begin concurrent statements and end architecture name. Okay, and as you can see in the example, architecture synthesis of synthesis. So okay, in here the name of the architecture is synthesis and name of the entity is AND gate. Okay, and it begins, and this is kind of conditions or concurrent statement as you can say it. So C is equal to A AND with B, and that is our AND gate. And last and final entity is configuration. A configuration defines how the design hierarchy is linked together. It is also used to architecture with an entity. Okay, so configuration is basically used to define the design hierarchy, and let's actually look at its configuration and its syntax and example. So configuration name of entity name is configuration declarations, and you can see here for architecture name, for instance labels, it is kind of bit long. Let us actually directly look at the example so you can understand it better. So configuration demo config of E1 detector test bench is for TB archi, which is architecture name, for UUT, which is a label. Okay, it is not name of architecture or anything, it is just a label. Okay, for UUT, and this event detector is component name. Okay, use entity, we are saying work, which is again library name, and under that library we have event detector, which is, as you can see, entity name again, and this is architecture name, SOP archi, and these are the three statements to end it. Now next we are going to see is, as you know, my project is BCD to 7 segment display decoder. Let's also understand what is BCD first. So BCD stands for binary coded decimal, and if you take a look at the BCD values, it is just the binary values, right? The 6 in binary is 0110, right? The 9 in binary is also 1001. The 2 in binary is 0010. So what is the difference between BCD and binary? Now let us take this example. If 25 is converted into BCD, it is 0010 and 0101, which means these 4 digits are equivalent of 2 and these 4 digits are equivalent to 5 in decimal. Whereas if you convert 25 in binary, it is 11001, which are completely different. Thus BCDs are generally used to display numbers from 0 to 9, and it is designed for that. Now let us also understand the second very important component of the project, and it is 7-segment display. So as its name suggests, 7-segment display, a display which is segmented into 7 parts. Now you can see this is the old 7-segment display which is used to display the numbers, but currently we are using the modern digital displays which use LEDs to display the number. Now you can see here are 1, 2, 3, 4, 5, 6, 7 sections, but you are missing out a tiny LED which is for decimal at the end. But for now we are not considering the decimal LED, so we can say this is a 7-segment display used to display numbers. But how does it display the numbers? As we have discussed, these are the basically 7 LEDs which are lined up. It are named like A, B, C, D, E, F and G in clockwise direction. Okay. Now suppose I want to display 1 on this 7-segment display, then what I will do is just glow the B and C LEDs, and rest of the LEDs will remain off, and that will result into something like this, which is 1, or you can see here it will result into something like this, which is obviously 1. And if I wanted to display the 0, I will glow all the LEDs except the middle one, which will result into which will result into visual of something like this, and it is equivalent to 0. Similarly, 2 can be clone like this, 3 can be shown like this, 4 can be shown like this, and from 0 to 9 we can display these numbers. But wait, let us understand a basics about hardwares of LED. Okay, so there are two configurations of 7-segment display. The first one is common anode and second one is common cathode. So as you know about LED, now, as you know, in the basics of LED, a LED is a diode and which have two terminals, cathode and anode. The anode is the positive one, the cathode is the negative one, and you supply positive charge to anode and negative to the cathode. Now, if 7 LEDs are connected together, now if the anode of all these 7 LEDs is connected together and converted into one single terminal, it is common anode. And if the cathode of all these LEDs is connected together and converted into single terminal, then it is known as common cathode. Yeah, the general configuration that is mostly preferred and used is common anode configuration, because in that configuration we can use the external power supply. Now I will also like to show the same logic of LED is being applied in our program. Like this is the entity, the second part is architecture. Now let's also took this very important part of the program, which is the switch case statement, as know it in C. So when the value of BCD is 0 0 0 0, then 7-segment display will glow the LED as follows: 0 0 0 0 0 0 0 1. Okay, wait. So the 7-segment display will glow the LEDs as follows, and these are the 7 digits if you didn't count it. So all the LEDs are cloned except the last one. So let us also verify this. By the way, if you don't know it, as we are using the common anode configuration, 0 means LED is glowing and 1 means the LED is off. Okay, now let us verify that will this configuration display the 0. Let's go to our diagram here. Yeah, so all the LEDs are glowing except the last one. A, B, C, D, E and F are glowing, and the last one, which is G, is not glowing, and as a result it will display 0, and that is perfectly correct. Now let us check some random number like 9. Yeah, let's see what happens in the case of 9. When we say when we say display the 9, let's see what happens. 0 0 0 0. Okay, all are glown except the last third LED. Now let us also verify that which is the last third LED, first, second, third. Yeah, so only the E is off and all the LEDs are on, and obviously which results into a display of something like this. You can see here only the LED number E, which is the last third LED, is off and all are on, and as a result we can see the 9 is being displayed. So yeah, I hope you understand the logic of our program. And now let's also look at our test code. So in the test code, what we are going to do is we are going to change the BCD value ranging from 0 to 9 for every 100 picoseconds. Yeah, so let us run this program. Yeah, so when BCD is 0, the 7 segment is 1. That's incorrect, right? No, because as we know, these are the there must be 7 digits, and our program does not value the zeros before 1, which means if there are zeros before 1, they are just ignored. So we are going to consider it. So 0 in BCD is 6 zeros and 1 in 7 segment. So 1 2 3 4 5 6 zeros, and then last one is 1, which means 6 LEDs are glowing and only the last LED, which is number G, is not glowing, and which results into 0. Always remember, this must be a 7-digit number in the binary. Okay, so how is 1 displayed? So it says 1001111. Let's also verify that. So 100, which means second and third LEDs are glowed, and rest of all is 1, which means they are off. So only B and C are glowed, and as a result you can see the 1 is similar, and as a result you can see the 1 is being displayed and it is similar. Thus you can check any of this, and we have finally verified our project. Thank you.
Zeal Education Society, redefining excellence.